Say good afternoon, welcome. Today I'm going to go through June examination grade 12, paper 1, but I'm going to focus more on section A, which is climate, weather and geomorphology, but I'm going to focus more on climate and weather. So the way I'm going to do it, I'll be looking at each and every question. I'll try to make it as easy as possible to understand, especially including some of the concepts that we have covered in climate and weather. But I just want to say that when it comes to weather and climate, the most important thing is when it comes to climate and weather, the most important is whatever we are going to talk about, we are supposed to know that we are more concerned with the elements of weather. That is your precipitation, which are various forms of water, of moisture, that falls from the sky to the earth. That is your precipitation. I'm talking about rainfall, I'm talking about hail, I'm talking about dew, I'm talking about drizzle, the different forms of precipitation that falls from the sky to the earth. And we are also concerned about the changes in terms of temperature. Is it going to be hot? Is it going to be cold? So that's another element that we'll be commenting on in as far as the topics are concerned. We'll also look in terms of cloud cover. Is it cloud? Is it clear? Is it partly cloud? We'll also look in terms of the wind direction and the wind speed. So these are the four elements that you are supposed to know in as far as the topics are concerned. Because obviously at some point we are going to talk about mid-latitude. Obviously we are likely to have heavy rainfall, we are likely to have maybe strong winds, we are likely to have floods. I think this has something to do with precipitation. The temperatures at some point will drop. Of course, it has something to do with temperature. Is it going to be cold or hot? Or in terms of cloud cover, is it going to be cloud? And also wind direction. Those are some of the things that you are going to, you should always be aware of when it comes to climate and weather. So the first thing, various options are provided as possible answers to the following questions. Choose the answer and write only the letter A to E next to the question numbers. Choose the answer and write only the letter A to D next to the question numbers. So this is a concept, and the concept that we are being assessed on here is urban heat island. This is the concept that we are being assessed on. So the moment you know what urban heat island is all about, then it becomes easier for you to answer the question. This is when the temperature of the urban areas are higher than the surrounding rural areas. That's what the concept of urban heat island talk about. Then we talk about isotherms. These are lines that are showing areas with the equal temperatures, with the same temperatures. Those are isotherms. Okay, so this is your map. With your map, what you have? You have got the CBD, which is the Central Business District, the suburban, these are the areas where you've got our residential areas, the park, you can see, of course, then you also have your rural areas. So we are saying now, when we want to explore this concept, we are saying this is when the area of the temperatures of the urban areas are higher than the surrounding rural areas. So that's what the concept of urban heat island is all about. Okay, so these lines, they are showing you the areas or that has got the same temperatures. Of course, you can see here, from here it's 66 degrees Celsius, but as you go away from the CBD, which means the closer you are to the CBD, the higher the temperatures. But as you move away, going towards the outward part of your CBD, okay, towards the rural, let me say rural or suburban, the temperature is decreasing. So it's high within the CBD, but it decreases as you go outwards. Okay, let's go to the first question. Okay, so the first question reads, the temperature range between CBD and the rural area. Temperature range between the CBD and rural area. All right, so you come back to your diagram. This is your CBD and your rural area. Okay, so what you do now, your CBD, you can see is 6. Okay, then your rural area, there is +1 or 2. These are the temperatures that we have within the rural areas. So it means the temperature range, you are going to subtract your maximum, which is within the CBD, which is +6, minus what we have within the rural area. You can see is +1 or +1 +2. Okay, so I'm going to subtract here. What do we have? We have got 5 degrees Celsius. We have got 5 degrees Celsius. Okay, then let's check as well. There's 2 within the rural area. There's 2 as well. So it can also be plus 5 minus 2 plus 5 plus 6, sorry, plus 6 minus 2, which can be 4 degrees Celsius. So if you look from the options that are given, it means now the temperature range, we are looking at the difference between the highest and the lowest temperature. What we have within the CBD is plus 6. What we have within the raw areas is plus 1 or plus 2. So we subtract highest minus lowest. So your answer here can be C or D. It can be C, which is 4 degrees or 5 degrees. Okay. Then the second one reads, the increase in the surface of the absorption of solar radiation restrict the cooling effect of the wind in the CBD. The options that are given here, we've got the motor vehicle, we've got the charred surface, we've got the natural resurfaces. So you answer from the options that are given. It is the tall buildings. It's the one that increased the surface area for the absorption, of the solar radiation and restrict the cooling effect of the wind in the CBD. So you answer the C. Okay. Then raw areas have lower. Raw areas have lower temperatures because they have albedo and water bodies than urban areas, 1.1.3. So you have got here, you can see from what we have here, it's what do they have? From what we have there, you can see from 1.1.3. You can see that we have got 2. What we have is lower albedo, okay, and more water bodies than urban areas. So your answer, we're saying it's here, it's lower albedo, then it has got more, which is 2 and 4. 2 and 4. That makes your answer D. So it means here it's what? It's D. There is, we have said it's C, and there we have said it's C or D. Okay, suburban areas are cooler than the CBD because they have, okay, what do they have? 1.1.4. You can see if we had to choose from the options that we have, they have got fewer, okay? They have got fewer. Then what else? Evapotranspiration is higher there, okay? So your answer there will be fewer and higher, which is 1 and 3. Where do we have our 1 and 3? Which means your answer there for 1.4 is C. Which means your answer here is what? Is C. Suburban areas are cooler than the CBD because they have fewer artificial surfaces and higher evapotranspiration. Okay. Then from there, what do we have? We have got question. Refer to the photo below of pollution doom over Johannesburg to answer question 1.1.5 and 1.1.7. This is a layer of pollution that is above the urban areas. That's what the pollution dome is. So the first question reads, the photo represents the pollution dome during air. So you can see from the picture that we have, this is during night in winter. This is during night in winter, which means you have got B as your answer there. Then 1.1.6, in the photo, pollutants are concentrated. You can see are concentrated from the options that we have here. It's further from, you can see with the height of the building, is further from the episurface due to the 1.1.6, okay, that is number 4, high pressure cell, which means we have got 1 and 4, 1 and 4, which means 1 and 4, what do we have? 1 and 4, which means our answer here is what? 1 and 4, our answer is A. Our answer is A, 1 and 4. Further from the episurface, you can see, further from the episurface, these are the tall buildings that you find within an urban area. You can see what is covered there. It means that is further from the episurface due to higher pressure cell, which is 1 and 4, which means your answer there is what? Is A. Okay. Then pollutants in the urban area mixed with radiation fog to form 1.1.7. That's your smoke. That's your smoke. Okay, that's your smoke, which is B. Then moving on to 1.2, choose the correct term and concept of the valley climates on column A that matches the descriptions and statements in column A. Write only Y or Z next to the question 1.2.1 to 1.2.8 in answer book. Okay, so here you've got the statements, there you've got the concept of the term. The slope suitable for the forest in the southern hemisphere. Remember when we talk about the valley climates, okay, the issue of aspect, which means the angle at which the sun rays strike the slope. So obviously in the southern hemisphere, north-facing slope are warmer as compared to the south-facing slope. So the slope of suitable for forestry, which means here it will be south facing because it has got moisture. It's the south facing slope. So it means your answer here will be Z. Then the precipitation forms when the temperature in the valley is above freezing point. Frost is when it's below freezing point. So it means your answer there is dew. Frost is when it's below freezing point. That's when we have got the frost pockets within valley, okay? It traps pollutants in the valley during the night. That's your invasion layer. That's your invasion layer. That's your invasion layer, okay? That will be your invasion layer, okay? Then the precipitation which allow impact farming products, which will impact farming products. Sorry about that. 1.2.4. This is frost. Your frost will impact. Okay, that is the frost through frostbite. Okay, forms when air cools to dew point as a result of terrestrial radiation. Obviously, we cannot say it's frost pocket because this has to be below the freezing point, okay? So our answer there is radiation fog, which is Z. Then people living in the valley slopes experience this wind during the day. During the day, it's anabatic. During the day, anabatic. Okay, during the day, it's anabatic. Okay, you can see here it shows anabatic. All right, anabatic. Then when it's sinking, it's cold, it's during the night. So there, the answer is anabatic. So anabatic, to be like this, then you see it rising from the valley going upwards, okay? Warm air is light, so it rises. Cold air is heavy, so it sinks. So that's why you can see here it's sinking. That is katabatic here, but here it shows anabatic, okay? A wind that develops in the valley during the night, so this will be your katabatic now because it's sinking, okay? Because cold air is heavy and denser, it's sinking. Here it's rising. That's your anabatic. So the correct answer is this one, they said. Then houses are built at this location to lower electricity bills. That will be at Y because that's where you've got your thermal belt. That's where you've got your thermal belt, where a parcel of warm air is trapped between two parcels of cold air at the top and also at the bottom within the valley. Okay, which means you're going to have something like this. Okay, we have warm air here, then we have got cold air, we have got what? Cold air here. So this will be your thermal belt. Okay, let's move on to the next one. Refer to the synoptic map below on mid-latitude cyclones. Refer to the synoptic map on mid-latitude cyclone. So when it comes to synoptic weather map like this, if you want to know the season, before I move on to look at the question, if you want to know the season that is shown on the synoptic weather map, the first thing that you do is you look at the date. You can see is 3 July 2024. Before we attempt to answer any question, 3 July 2024, which means already it shows that it's in winter. Okay, and our mid-latitudes are common, obviously, in winter, of course, because they affect the weather of Cape Town. The next thing you can see, where is our cold front is closer to Cape Town. Okay, it shows you that it's winter. That's evidence number 2. Evidence number 3, you can check your high pressure systems. In winter, they move further north. They move further north. You can see how they are positioned. Your South Atlantic high and your South Indian high, they move further north during winter. Okay, then also during winter, the Kalahari High is very active, which means there's too much subsidence in the interior, which means the air that is coming from the wind that is blowing from the two high pressure systems, they cannot go above the escarpment or get into the interior. Why? Because there's too much subsidence. There's a lot of cold air that is sinking within the interior, which means that there is no condensation that will take place. There is no clouds that will be formed. They are clear, calm conditions within the interior. Okay, so from what we have now, let's move on to the questions. Okay. Name what we call the series of mid-latitude cyclones in succession. They are called families. They are called families of cyclones. Families of cyclones. Families of cyclones. Okay, that's what we call them, family of cyclones. You can see they move in families. It shows the different stages in the development of mid-latitude. Okay, they are called families of cyclones. Name the front A and sector B in the synoptic weather map. Front A, you can see, is the triangle, that's a cold front. B, that's where you've got your warm sector. That's where you've got your warm sector. So A is cold front, B is your warm sector. Then what influence does the South Indian anticyclone as shown on the synoptic weather map, we have on the path followed by the mid-latitude cyclone. So this is where you've got your South Indian anticyclone, which is a high pressure. This is where you've got you have your South Atlantic high pressure, which is also a high pressure. So it's saying what influence does the South Indian anticyclone shown on the synoptic weather map have on the path followed by the mid-latitude cyclones? 1.3.3, it blocks or it blocking high pressure, their path to the east. It blocks or blocking high pressure, their path to the east, or it causes them to change their path to the southeasterly direction, okay? Cause them to change their path to the southeasterly direction. You can see the direction that they're following is southeasterly, that they are moving, causing to change in the southeasterly direction, or they're moving towards the east. You know also the movement of our mid-latitude cyclones. It moves from, it's affected by the westerlies, so it moves from west to east. It moves from west to east. Okay, you can see the way it's moving, southeasterly direction. So cause them to change their path to southeasterly direction. That is the answer for 1.3.3. Then 1.3.4, the mid-latitude cyclone. The mid-latitude cyclone C. In the cold occlusion stage, draw a labeled cross-section of C on the synoptic weather map. Marks will be awarded for the cross-section cold air, cool air, and warm sector. So for this one now, the way you do it now is you want to draw a cold occlusion. So you have got the way you draw it. This is, all right, let me do it like this. This is your cold, okay? This is your warm, okay? You need to know the positioning. So here you have got cold air. There you have got your warm sector. There you have got cool air. Cool air. So this is the cross section, okay? The cross section of the cold occlusion, okay? So what do you have here now? This is touching the surface. That's what you need to take note of. This cold front is touching the surface. The positioning, this is where you have got your cold air. This is where you've got your warm air. This is where you've got your cool air. So behind a cold front, there is cold air. Ahead of the cold front, there is warm air. Behind the warm front, there is warm air. Ahead of the warm front, there is cold air. So you need to know the positioning. Where is your cold air? Where is your warm air? And where is your cold air? Same applies if you're going to ask you to draw a warm occlusion. Obviously, it was going to be like this. So it means here you have got your warm, that remains your warm sector. Here is cold, there is cool air. Okay, there is cool air. So this one will become your warm occlusion. This one will be your cold occlusion. So that is the difference. The difference is that on a cold occlusion, the cold front touches the surface. You can see it touches the surface, and the positioning of your cold and cool air. Cold air is behind the cold front, warm sector in between, then you've got cool air ahead of the warm front. When it's a warm occlusion, which means your warm front is touching the surface, then you've got cool air behind the cold front, then warm sector, then you've got cold air ahead of the warm front. That is the difference between the two. So this is what you're supposed to do. This is a cross section. This is the correct cross section. Write the cross section of the cold occluded front. Of course, which means when you talk about occlusion, we are talking about the merging, okay? They've been joined, they've merged. That is the cold front and then warm front. That's basically what it's all about. Which means we are saying if you check, this is a cold front, this is a warm front. They have merged here. That's what we mean when you say it is occluded. Okay, that's what it means. Okay, so you have seen how it's done there. Then 1 mark is for the indication of the warm sector, which we have done. This is your warm sector. Then another mark is the location of the cold air. This is where your cold air. The location of the cool air. This is where it is. Then 1 mark indication. Obviously, 1 mark for correct drawing of the cross section is correct. So it means you get all your marks 1, 2, 3, 4. That's how you got these 4 marks. Account for the development of weather in the Cape Town, that Cape Town experience on 3 July 2024. 3 July 2024. What type of weather did they experience? So here what they are asking you to do is you should be familiar with the weather conditions that are associated with the cold front. The weather conditions that are associated with the cold front. This is what they are asking you indirectly. So it means we are going to talk about the heavy rainfall due to the formation of cumulonimbus clouds. That's number one. Okay, you know that obviously here, if I'm to use the diagram, obviously this is your cold front. There's going to be some cumulonimbus cloud here. We have got rainfall. Of course, there's strong wind where we have got our cold air. Obviously, there's a steeper pressure gradient here. There's a strong wind. This is what caused occlusion to take place, because this one will be moved at a faster speed because of the strong winds. So that's why it ended up catching up with the warm front. This is what caused occlusion, because there is steeper pressure gradient. There are strong winds behind the cold front. This is what caused the cold front to catch up with the warm front, causing an occlusion. Okay. So we are saying now for this question now, count. The first one is heavy rainfall due to the formation of cumulonimbus clouds, the strong wind due to the steep pressure gradient, strong upliftment of warm air. Remember, you've got your cold air. So what is happening is the warm air ahead of the cold front will be uplifted. Once it's uplifted, remember, warm air is light and also it's moist. So it's as it rises. It means because it's uplifted by the cold air, what will happen is it cools. It's going to condense. Once it condenses, clouds form, especially clouds of vertical extent like your cumulonimbus clouds. Then once clouds are formed, then we have precipitation. But in this case, we are talking about heavy rain, the torrential rain that is from your cumulonimbus clouds. So we are saying that heavy rainfall due to the formation of cumulonimbus cloud, the strong winds due to the steep pressure gradient. Okay, the strong winds because here there's cold air. So there's steeper pressure gradient, which means the isobars behind the cold front, they are very close to each other. Okay, they are short areas of equal pressure. Okay, so they are very close to each other, which means there's a steeper pressure gradient, there are strong winds. So the strong winds now, cold air is going to uplift the warm air. Once it's uplifted, it rises, it cools, clouds form, then there's heavy rain or precipitation. Okay, then what else? The decrease in temperatures due to the cold front behind the cold air. Obviously, the cold front is approaching, so it means it has an effect. It will reduce the temperatures. That's what it's all about. All right, let's move on to the next one. 1.4, refer to the infographic below of Tropical Cyclone Hamane. Tropical Cyclone Hamane. Okay, Tropical Cyclone CC Hamane made landfall in Piscana Commune, Sava region, bringing heavy rains and cloud floods to the north and northeast on 27 March. The 9th tropical cyclone depression system of the current cyclone season began developing along the northeastern coast of Madagascar on 25 March. Some districts in the northeast have received heavy rainfall over the past few days, but the Sambava district recorded 300 millimeters of rain on 26 March alone. Madagascar issued a red alert of the imminent danger of the Diana and Sava regions, a yellow alert of menace of the Ambatoswa and Anala Girovo regions on 27 March. So the question now is, how many tropical cyclones have developed before Tropical Cyclone Hamane? Remember, they are named alphabetically. So we are saying before. So take note of before Tropical Hamane. So you've got A, B, C, D, E, F, G, 7. So before G, which is Hamane, they are 6, which means here they are 6 before G. So it means 6, okay. 6 of them occurred before Hamane. When did Tropical Hamane make landfall according to the infographic? You can see when it reaches land, it's on the 26th and 27th. That's when it reaches land here in Madagascar. That's when it reaches land, the 26th and 27th, okay? Describe the general direction by the Tropical Cyclone Hamane, 1.4.3. Remember, it's driven by the easterlies, the tropical easterlies. So it moves from east to west. It moves from east to west or westerly or in a southeasterly direction. Remember, in a southeasterly direction. What do I mean by that? Southeasterly direction, just to illustrate, okay? We have got this. We have got here at 0 degrees, okay? There, okay. Usually it starts at 5 degrees south. Why? Because of lack of Coriolis force within the ITCZ. So it moves from here until it reaches your 30 degrees south. That's when it reaches the land. Now it means there's more friction. It has lost a lot of moisture. So it's moving from here, heading towards that direction. That's basically what you're trying to say. The tropical cyclone moves, which means from here, Okay, temperatures has to be above 26.5 degrees Celsius. That's one. It has to be within the warm oceans, so that obviously there has to be release of latent heat. There have to be condensation that takes place, among other reasons. These are the conditions that are necessary. But I've already answered that it moves from east to west or in a westerly direction. Then the next question, 1.44, reads, discuss the negative environmental. The negative, the question is on the negative environmental impact on the tropical Hamane, on the coastal region mentioned in case study. Okay, the negative, which means the focus is only on the environmental, not anything social, not anything economic. So it means we are looking at the effects on the environment, okay, but are negative. Okay, so we are looking at things like coastal areas will be flooded. Obviously, there will be flooding of the coastal areas. That's a negative, okay? A negative impact, okay? What else? We can talk about the soil will become polluted. It will become salty. There can be increased soil erosion. The beach and the sand dunes will be washed away. The coastlines will be reshaped. We are talking about the destruction of natural habitats, the destruction of biodiversity. Those are some of the things that you can include. Destruction of natural habitats. Remember, the focus is on the natural environment. What are the effects? Okay. Then in a paragraph of approximately 8 lines, explain why Madagascar is still vulnerable to the effects of tropical cyclone despite huge improvements in early warning system and disaster relief programs. So if you look at Madagascar, it's a developing country. It's very poor. It's a developing country. So you find that some of the things that answers this question is, number one, it's a less developed country. You know, less developed countries, they've got a lot of challenges. They've got challenges in terms of them lacking financial resources. So it's poor, it's developed countries, okay, less developed country. Then you can also see that there are people that are living in remote areas, which means some of these areas are not accessible. They are remote. So that's what makes it a problem, despite them having improvement in terms of their early warning system. You can talk about most people from farm on floodplains which are prone to flooding, which means this makes them vulnerable to these problems that are coming as a result of flooding. Okay, you can also talk about floods, flash floods. Okay, often okay in areas not directly hit by the cyclone. That can also be another reason, or lack of media coverage to warn people. Lack of media coverage to warn people. The government does not give assistance when it comes to rebuilding. The clinics and hospitals are poorly equipped with both personnel and medicine. Remember, you have to take into account that this is a developing country, a less developed country, which means it has got challenges in as far as financial resources are concerned. Okay, let's move on to the next one. Then 1.5, start the diagram and case study on Berg winds below. And Tlhahla Stole, a weather forecast of the South African Weather Service, predicts that the province could experience damaging inland winds on Sunday. A yellow level 2 warning has been issued due to the cold front moving towards the south interior of South Africa. Ahead of the cold front, we have northeasterly back winds. These winds lead to warmer temperatures, especially over the central and eastern parts of the province. As a result of these strong winds and warm temperatures, FDI, which is Fire Danger Index, warning has been issued on Sunday. So when it comes to Berg winds, what you need to know when it comes to Berg winds, what is important is, when it comes to Berg winds, is this usually happens in winter. That's what you need to know. It happens in winter, all right? This is where we have got our South Atlantic high, we have got our South Indian high, we have got our Kalahari high, which means there is high pressure in the interior. Then there is low pressure at the coast. There is low pressure at the coast, which is your coastal low. So we are saying now, when you talk about Berg winds, obviously this is in winter. We have got high pressure in the interior. This Kalahari is very active, which means there's too much subsidence here that is taking place, so that rising air from both the high pressure system cannot go above the escarpment. So there's too much subsidence that is taking place. Why? Because our ITCZ is moved on top of the equator. Our Kalahari is active. Our South Atlantic high is moved northwards. Our South Indian high is moved northwards as well. So there's too much subsidence. There's high pressure in the interior. So the question now, it reads, define Berg winds. Define Berg winds. Okay? The Berg winds is a hot, dry wind that blows from the interior of South Africa to the coastal regions in wind. So it blows from the interior, that is in the interior of South Africa, to the coastal areas in winter. So you have to define in terms of Where is the high pressure moving from? It's moving from the high interior towards the coast where we have got the low pressure. Usually it's in winter, so you need to make sure that you include all that. So there is your Kalahari high. So we are saying now, it's more like this. We have got high pressure, then we have got low pressure at the coast. So when you are looking at the coast now, we are saying now, when it's coming from here, it's dry and warm, dry and hot. So as it approaches the coastal low, here is called offshore. Offshore, which means it's hot and dry. Okay, but as it moves now, remember it's clockwise, on the other side here, it has now gathered some moisture, it has absorbed some moisture from the ocean. Now on this other side is called onshore. Now it's warm and moist, which means the weather conditions here, where it's offshore, where it's hot and dry, is different from where it's onshore, where it's warm and moist. So here it's offshore because it's coming from the interior where it's hot and dry. Here now it has absorbed some moisture on the ocean. Now it's going towards the interior. Now it is warm and moist. That's what is happening there. So when it comes to Berg winds, you need to know the position of your high pressure system in the interior, position of the low pressure system at the coast. So it moves from the high to the low. Here it's offshore. It's likely to be clear skies, dry weather, obviously. Why? Because the air mass is dry and warm. Here it's warm and moist. Okay, remember the movement of air mass. Air mass is a large body of air with the similar characteristics in terms of temperature and the moisture content. So here it's dry and hot, the moist offshore. Then the onshore now, since it is absorbed moisture from the ocean, now it's warm and moist. Okay, that's what happened there. According to the weather map, which two pressure system is responsible for the occurring of Berg winds? So that will be your Kalahari high and your coastal low. Kalahari high and your coastal low. That will be your Kalahari high in the interior and your coastal low. Then what else do you have? A Berg wind is obviously it's an offshore. Why? Because it's hot and dry. It's coming from the interior. It's hot and dry, so it's an offshore here. Then explain why the South African Weather Service issued a fire danger index on 4 August 2024. Why did they issue? Okay, so the answer there is the wind. The wind dries vegetation and make it vulnerable to veld fires. The wind is strong and can easily spread veld fires. Remember, the Berg wind is associated with hot, dry wind. So that hot, dry wind, it dries vegetation, it makes it vulnerable to veld fires, or the wind is strong and can easily spread veld fires. Then the last one, 1.5.5, suggests strategies that the local government can implement to reduce the impact of Berg winds on the natural environment of the coastal. Okay, so here, strategies, what the government can implement to reduce the impact of Berg winds on the natural environment. So we are saying we are looking for the strategies is in past. Okay, strategies that the local government can implement to reduce the impact of Berg winds on the natural environment of the coastal range of KZN. So the first thing that we can do, they can implementation of fines and imprisonment of arsonists, those ones who are starting this fire. Okay, they can implementation of fines and imprisonment of arsonists. They can also put legislation against the starting of fires during the winter season. They can also bring awareness, that is educate the local communities about the impact of Berg winds. They can also monitor and manage the fire risk. These are some of the things that they can do. They can plant grass and vegetation in areas with sparse vegetation to reduce erosion. They can also implement the controlled burning of vegetation to reduce the risk of veld fires, or they can create fire breaks around forest plantation to reduce the spread of veld fires. So I think I've come to an end of the first part of section A. I was basically looking at climate and weather. Like I've already emphasized, when you're looking at climate and weather, the most important thing is we want to comment on the weather patterns, but in relation to the elements of weather. That is your temperature. Is it going to be hot or cold? We comment in relation to the cloud cover. Is it going to be overcast, partly cloud, or clear? We comment in relation to the precipitation. What are we likely to have? Have rainfall, light rainfall? Are we likely to have thunderstorms? Are we likely to have torrential rainfalls? Are we likely to have rainfall such as drizzle, light rain? So that's part also of elements of weather. Then the last part in terms of our wind speed. strong winds, what is the wind direction, among other things. So all in all, we have looked at the concept of urban heat island, applying this diagram that you have here, which shows the areas of urban areas having higher temperatures than the surrounding rural areas. We have also analyzed the pollution dome, I think, using this diagram, as you can see, which is more dominant, especially night in winter. We have also looked at this diagram, which talks about the paliclimates. That is your anabatic, okay? That is your katabatic. You can see it's cold and it's sinking. Your anabatic, it's warm. That is why it's rising, okay? We have also explored the issue, the aspect of aspect, whereby we are looking at which slope receives more sun rays, okay, of which in the southern hemisphere is the north facing, that receives more sun rays as compared to the south facing slope. That's why it's suitable for forestry. We have also looked at mid latitudes and how do we find out, okay, how do we determine whether it's winter or summer? Obviously, you look at the date. That's what I've emphasized. You also look at the position of your cold front. It's close to Cape Town. You look at the position of a high pressure system. They have moved further north. You look at also position of the Kalahari High. We have also looked, we have also explored or looked at the cross section of cold occlusion stage, where we say that you have got your cold air behind your cold front, warm sector, behind your warm air, you've got warm air, then you've got a cool air. So when it comes to cold occlusion, you need to know what is the position of a cold air is behind the cold front. Warm sector will always be in between. Then your cool air will be ahead of the warm front. Then your cold front, it has to touch the surface. That is cold occlusion, okay? Warm occlusion, obviously your warm front has to touch the surface. Then what is the position of, where is your cold air? Cold air obviously is ahead of your warm front. Then you've got cool air behind the cold front. Then you've got your warm sector. So that is all for today. Thank you so much. I'll see you in the next video, where maybe I'll be looking at geomorphology. Thank you.